All right, we're going to go over scientific notation. Scientific notation is a shorthand way of writing very large or very small numbers. What happens when you multiply a number by 10 or a power of 10? In other words, if I had 3 times 10, you would make that 30. If I did 3 times 100, you make that 300. And if you notice, every time you're taking 3, and if it's timesing it by 1, 0, that moved that decimal to the right. If you multiply it with 2 zeros, it moves the decimal twice over. So that's how that's going to help us with scientific notation. There are some rules in writing numbers in scientific notation. 1, the coefficient must be greater than 0 and less than 9. Less than 10. So 1 through 9. The base must be 10. The exponent shows the number of places the decimal must move, either right or left. So we have this term here is called our coefficient. That has to be numbers 1 through 9. Then you have your base. This always has to be the 10. And then you're going to have an exponent. And that exponent's going to tell me if I'm going to move right because it's positive or left because it's negative. Okay, we're going to start with scientific to standard. So this is a number written in scientific notation. So we're going to take this part of the number, 1.35, and we're going to rewrite it. And our exponent is 5. That tells us how many times we're going to move this decimal place. Our decimal place needs to move 5, but because it's positive, we're going to move it to the right. 5. 1, 2, 3, 4, 5. And if you can guess what goes in there, those are going to be zeros. So we're going to rewrite our number, replacing the zeros, and now our decimal is at the very end. So your answer should be 135,000. Okay, we're going to try that again. You feel free to pause and try it on your own. 5.09. We're going to take our decimal and we're going to move it 8 times to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means that we added a total of 6 zeros. So 5, 0, 9, 1, 2, 3, 4, 5, 6. Our decimal's now at the end. We're going to add in our commas to be able to read the number correctly, 509 million. Okay. So I'm going to write our 2.4. And if you notice, this time our exponent is a negative number, which means we're going to move it to the left. 1, 2, 3. We're still going to fill those spaces in with zeros. And remember, this time our decimal's at the very beginning. So when you're writing numbers less than 1, you have a 0 at the start, so 0.0024. Okay. So here's another one. We're going to write this part down, 6.834. We're going to take our decimal and we're going to move it 5 times to the left. Again, 1, 2, 3, 4, 5. And there, so we're going to fill in with 4 zeros. So point, 1, 2, 3, 4 for those spaces that we just added. 6, 8, 3, 4. And again, to make it correct, you put your 0 at the beginning, the leading coefficient. Hopefully you're noticing that numbers that have a positive exponent move to the right, which makes the number larger, and when it's a negative, it actually makes the number smaller or closer to 0. Okay, so scientific to standard notation. If the number is greater than 1, the exponent is positive. So a positive 8 exponent in this example, that number is greater than 1. It's a positive exponent. If the number is less than 1, the exponent is negative. So negative 3, this number is a small number, very close to 0. So it's not going to be less than 1, or less than 0, it's going to be less than 1. So it's going to be smaller than 1, but it's still a positive number. The exponent is the number of times you move the decimal. So again, that's not how many zeros, It's how many times we moved the decimal. Very important difference. Now let's try standard to scientific notation. So we're going to review some things that we learned. The coefficient must be greater than 0 and less than 10. So 1 through 9. The base must be 10. The exponent shows the number of places you move the decimal, right or left. So this one, so again, this one's already in standard form, so we're kind of working our way backwards. So first thing I'm going to write is the number they gave me. Now, if you recall something about scientific notation is I can only have one digit. Currently the decimal's here, even though it doesn't show it. We should know a decimal's at the end of a number. We can only have one digit in front of the decimal. And right now we have a total of 5 digits in front of the decimal. So we need to instead have the decimal go between the 1 and the 9. Now I have a single digit in front of the decimal. I'm going to stop once I see these zeros. We're going to change that and we're going to get rid of them. And we're going to put times 10. Now I need to count how many decimal places did I have. So I just put the decimal here. Currently it's here. How many decimal places is that? 1, 2, 3, 4. That tells me my exponent. Now this number was greater than 1, so it's a positive 4. So my answer is 1.98 times 10 to the power of 4. Okay, let's try this one. So I have the decimal at the end of my number. Instead, I can only have one digit in front, not all of these digits. So it should go here in between the 2 and the 3. Then there's only one single digit, a 2, in front of my decimal. I can only have one digit in front of the decimal. So 2.34, I don't need any zeros because we're going to represent that with my exponent. So times 10. Now, my decimal is here. It used to be there. How many digits are there now in between? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 place values. That's my exponent. Not 13 zeros, 13 place values. And the number is greater than 1. That is a positive exponent. Excuse me. Okay, let's try again. Right now, my exponent has a 0 in the front. I needed to have a single digit greater than after 1. So 3 would be the first digit. So I needed to say 3.45 because now my digit is 1 through 9. 3 being a number that's 1 through 9. This number has to be 1 through 9. So 3.45 times. Base is always 10. So right now it's here. I need it to be here. I need to count how many place values is in between the two decimals. 1, 2, 3, 4. That number is less than 1, so it's a negative exponent. It's negative 4. 3.45 times 10 to the power of negative 4. Okay, let's try again. So right now my decimal is here. I need to have it 1 through 9. 7 for number. So my decimal is going to be 7 digit. That's 9 times 10. So I need it to be here. This here. So how many decimal places are there between 1, 2, 3 decimal place values? So 3 is my exponent. That number is less than negative 3 plus 7.24 times 10 to the power of negative 3. Again, it needs to be 1, 2, 3 decimal places. Okay, so remember, if the number is greater than 1, the exponent is positive. So 84,912 is a greater than 1 number, and my exponent is positive 4. If the number is less than 1, the exponent is negative. Smaller numbers have some negative exponents. So 0.00265, that is smaller than 1, so my exponent is negative 4 because it's smaller than 1. The exponent is the number of times you move the decimal, not, again, it is not how many zeros.